Today we're going to be talking about adding and subtracting polynomials, which is just a fancy way, or maybe a less fancy way, of saying combining like terms. There are two ways to do it. I'm going to start by showing you the vertical way, just because that may be a little bit easier. So when you have two polynomials that are being added, we don't have to worry about the signs of any of them yet. So what we can do is actually just identify, okay, the highest degree of polynomial is x to the third over here. So we don't have that in the other polynomial expression, we just have x squared. So what we're going to do is we're going to stack the polynomials. So the first step is to make sure that the polynomials are in standard form, and this only applies for the vertical way of adding them. So in this case, they're both already in standard form in descending degrees, so we don't have to worry about it. What we're going to do is we're going to go ahead and stack them, so I'm going to put them like this, and I don't have to worry about the sign or anything. As long as you have them being added, you don't have to stress about the signs of the second polynomial. So in this case, because it's plus, we don't have to worry. So the second polynomial, the highest degree is x squared, which means it's going to go underneath the x squared in the other expression. So from there, we can just combine like terms, adding vertically. So -1 plus 5 becomes 4. So -1 plus 5 becomes positive 4. -3x plus -7x becomes -10x. 1x squared plus 4x squared becomes 5x squared. And -4x to the third isn't added by anything. So this would be our final answer. So I recognize I didn't write out the rest of the steps. So here they are. The second step is to stack the terms, and the third step is just to add them. Go ahead and pause the video so you can copy those down real quick. So the other way to add polynomials, which is potentially more difficult, is to just add them horizontally, which we've covered in the year before, also in Math 7 very briefly. So you can see how I put all these terms in boxes. So the x to the third is by itself, both of the x squared terms are in pink, etc., etc. So I could rewrite them like this, and then from there I could combine like terms. This method also works, and in fact, when we're subtracting polynomials, you may find this helpful. In the end, it's up to you how you want to do it. This is just another way. Here's an example of subtracting polynomials, and here it is slightly more complicated. Because there is a negative here, we have to remember that this is actually a -1 that is multiplying everything inside this parentheses here. So because of that, when we write out our polynomials, and I'm going to start with the vertical way of solving these. So again, I have to make sure they're in standard form, which they are. I'm going to then stack them, but then when I write the polynomial here, I have to remember it's being subtracted. What happens then is I rewrite it like this, and it's still in parentheses, so you can see that I haven't distributed this negative on the outside here. And when I do, when I distribute this negative, it will change the sign of everything on the inside. So because of that, I'm going to write a new statement. Instead, I'm going to write 9x to the third minus 7x squared plus 8x minus 10. And on the bottom, I'm going to take this, and everything on the inside of this statement here will flip signs because of this negative on the outside. So I'll have positive 8x squared minus 7x minus 22. So from there, we just go back to what we were doing. We add like terms vertically, so -10 plus -22. 8 minus 7 is positive 1. -7 plus 8 is positive 1x squared, and 9x to the third. So this would be our final answer. So what you could do, before you even start adding the polynomials, is distribute the negative sign right away. So you could rewrite this statement, and after it's been rewritten, you could use either the vertical or the horizontal method of solving it. Either one is up to you, but either way, you're going to have to change the signs on the inside of whatever is being subtracted. So again, you could follow the other way of adding like terms. But either way, it's up to you. You can choose to solve vertically or horizontally, and you will still get the same answer. So here's another example, and right off the bat, you may notice that you have different degrees in each polynomial. So this one has x to the fourth, x squared, 7x, while this one has x to the fourth, x to the third, x, and then a normal number. We also notice that this polynomial is being multiplied by -2. And I suggest before we do anything, we just go ahead and distribute that first to make our lives a little bit easier. So you see I've inserted the plus here to show that the -2 is now multiplying everything inside of the parentheses. So when I rewrite this, I can write my second polynomial like this, where I see that every number on the inside has been multiplied by -2, and also I've rewritten as addition, since we've gotten rid of the -2 by distributing. Now when I stack them, I have to be very careful about how I do that. When I write it, I'm going to leave a space starting with the highest degree for every degree after it. So I'm going to start by saying x to the fourth plus nothing minus 2x to the second plus 7x plus nothing. Underneath it, I'm going to do the same thing, -6x to the fourth, and here I'm going to put minus 18x to the third, and you'll notice it's underneath just like an empty space. That's okay. Okay, there is nothing for x squared in this expression, and so then we're just going to write minus 20x over here, minus 4. So when I add them, I usually start from the right. 0 plus -4, 7 plus -20, -2 plus nothing, -18 plus nothing, and 1 minus 6. So the final expression has all of the terms, even though the original expressions didn't.